This morning, the FAA is investigating a Boeing cargo flight that got lost over Kansas and landed at the wrong airport. The 747 Dreamlifter was traveling from New York to McConnell Air Force Base.
November 20th, 2013. A Boeing cargo plane lands at the wrong airport in Kansas. Completely wrong airport. Inside, $200 million worth of 787 parts supposed to be in Seattle right now. Without those parts, Boeing's entire assembly line freezes. The pilot can't take off with full fuel and full cargo. He's trapped at this tiny airport. The plane he's flying? One of only 4 in the entire world that can do this job. Back in 2013, there were only 9 specialized aircraft in the world keeping Boeing and Airbus alive. 9. That's the entire global fleet. Without them, Boeing and Airbus don't just slow down. They completely stop building airplanes. So the question is, why does a $3 trillion industry depend on 9 planes that look like they were designed as a joke? The fragile system. Here's what most people don't understand. If one of these cargo planes doesn't land today, the Airbus A350 assembly line in Toulouse goes completely silent. 6,000 workers standing there waiting for wings, stuck somewhere over the Atlantic. The wings aren't late because of weather. They're late because the Beluga that carries them is literally the only plane in the world that can fit an A350 wing inside its cargo bay. Boeing has the exact same problem. Bigger, actually. The 787 is built in 8 countries across 4 continents. Japan builds the fuselage and wings. Italy builds the stabilizer. France makes landing gear. South Carolina does mid-fuselage. Washington handles final assembly. These sections cross oceans multiple times per week. Right now, 4 Dreamlifters fly these same routes on repeat. If even one gets grounded, the system breaks down quickly. Why normal transport fails? Why can't they just use trucks or trains or ships? They tried. All of them. Every single one failed. You can't truck an A350 wing because it won't fit under overpasses. Even if you could find a route, it's too wide for turns through villages built in the 1500s. You can't put it on a train because these massive wings exceed dimensional limits of standard rail tunnels and cargo systems. You can't ship it by boat because it takes 30 days to cross the Atlantic. Assembly lines burn cash while workers wait. You can't use a normal cargo plane because even the biggest freighter has a hold only this big, but an A350 wing is this big. The math just doesn't work. Here's the problem nobody saw coming. Airplanes became modular before logistics figured out how to move the pieces. Companies wanted to build wings in Wales and fuselages in Germany because it was cheaper, but nobody asked how you actually move enormous wing sections on a tight schedule. The Beluga solution. Rewind to 1991. Airbus has parts scattered across 6 European countries. They're trying to build the A340, which has bigger wings than anything they've built before. They started by borrowing NASA's Super Guppy, built to carry rocket parts. It worked for smaller models, but the A340 was too big. The wing literally wouldn't fit. No way to move parts from factory to final assembly. Imagine being an Airbus engineer when someone says the wing won't fit. You've got 18 months until launch. If you don't solve this, the whole program dies. Thousands of jobs disappear. So they did something insane. In 1995, they unveiled the Beluga, an A300 they cut the top off of and grafted this enormous bubble onto. It looks like a mistake, but when you see inside you understand why. The space is big enough to swallow a house. The nose tilts upward. They slide the wing in on rails. Whole process takes 45 minutes. Production time cut in half. Cost dropped 30%. It worked. Boeing's global gamble. Then came 2003. Boeing announces the 787 Dreamliner, promising revolutionary materials and fuel efficiency. Behind the scenes, they didn't just copy Airbus. They supercharged it. Went fully global. Fuselage from Japan. Wings from Japan. Stabilizer from Italy. Landing gear from France. Mid-fuselage in South Carolina, final assembly in Washington. Boeing consciously chose to distribute manufacturing globally for cost reasons, created an entirely new logistics challenge. One massive problem: how to move 787 fuselage sections across the Pacific Ocean on a schedule that keeps assembly lines running. Here's what changes how you understand this. Airbus built a weird plane to support their existing manufacturing strategy. Boeing redesigned their entire manufacturing strategy to require a weird plane. They bought retired 747s from airlines and did something crazy. Cut these planes open. Removed huge fuselage sections. Added a massive cargo section that swings from the tail. The whole process cost over $1 billion across 4 aircraft. When the tail swings open, you see a cargo hold specifically designed to fit 787 fuselage sections. Basically nothing else. 2 different solutions. Both look ridiculous. The Beluga loads from the nose for maximum volume. The Dreamlifter loads from the tail for specific sections. The Beluga carries 47 tons. The Dreamlifter carries over 100 tons. In 2013, there were 9 of these planes supporting a $3 trillion industry. No backup fleet. The system is incredibly fragile. If one aircraft goes down for maintenance or faces mechanical issues, production schedules immediately come under pressure. Assembly lines operate with zero buffer inventory. Components must arrive within days, or workers literally stand idle. The Kansas incident, which brings us back to that November night when the Dreamlifter landed at the wrong airport. Boeing engineers spent the night calculating if the plane could take off. 3 options, none good. Option 1, offload cargo and shut down assembly. Option 2, offload fuel and stop short of destination. Option 3, take off at performance limits with reduced fuel and full cargo. They chose option 3. Next morning, the Dreamlifter used every inch of runway and barely cleared the trees. This was a $300 million aircraft taking a calculated risk because stopping production was worse. Think about that. Landing at the wrong airport became a multi-million-dollar crisis, not because the plane was damaged, because the entire production system has zero margin for error. The evolution continues. By 2019, Airbus realized the A350XWB was too big even for the original Beluga. So, they built the Beluga XL. They're so aware this looks absurd that they literally painted a smile on it. Today, in 2026, there are 15 of these specialized aircraft in the world. 6 Beluga XLs, 5 original Belugas being phased out, 4 Dreamlifters, all supporting global aircraft production. Here's the pattern. Bigger passenger planes need bigger cargo planes, which enable even bigger passenger planes. Boeing's 777X has wings so large they fold at the tips. It might need a new Dreamlifter variant, and the cycle continues. The economics of ugly. Why would Boeing and Airbus spend billions on planes this ugly? Because the alternative is worse. Building everything in one location means higher labor costs in expensive countries, loss of political leverage. Countries want manufacturing jobs, inability to source specialized expertise globally, massive single point of failure risk. Distributed manufacturing means lower costs per component, political benefits. Every country wants a piece. Access to specialized suppliers, better negotiating leverage, but it requires moving impossibly large objects across continents on tight schedules. The Beluga program cost Airbus approximately $1 billion to develop. The Dreamlifter program cost Boeing over $1 billion. Sounds expensive, until you realize the 787 program generated over $500 billion in orders. The A350 program generated over $200 billion in orders. Spending $1 billion to enable $700 billion in revenue isn't crazy, it's necessary. The hidden dependency. Here's what keeps Boeing and Airbus executives awake at night. These 15 aircraft represent single points of failure for the entire commercial aviation industry. Dreamlifter goes down for maintenance. 787 production slows. Beluga XL has mechanical issues. A350 deliveries delay. Weather grounds the fleet for a week. Assembly lines freeze globally. There's no Uber for airplane-sized cargo. No rental fleet to call. No backup plan. The entire system depends on these ugly planes flying the same routes every single day without fail. And here's the terrifying part. They can't build more quickly. Converting a 747 into a Dreamlifter takes years. Building a Beluga XL takes years. If demand suddenly spikes, there's no way to scale production fast enough. The ugly planes become the bottleneck for the entire industry. The future of ugly. What happens next? Boeing and Airbus are both designing even larger passenger aircraft. New materials, new aerodynamics, new capabilities, which means even larger components that need transportation. The 777X already pushed the limits. Wings so large they need to fold. The next generation will be worse. Some engineers propose building a new generation of cargo aircraft specifically designed for oversized aerospace components. But that takes a decade and billions in development. Others suggest bringing manufacturing back to centralized locations. But that eliminates the cost advantages that made distributed manufacturing attractive in the first place. The most likely outcome? More ugly planes. Beluga XXL. Dreamlifter Gen 2. Even more ridiculous-looking aircraft. Because the fundamental problem hasn't changed. Passenger aircraft keep getting bigger. Components keep getting larger. Logistics keep struggling to catch up. This whole thing started because companies wanted to build planes cheaper by spreading production across the world. It worked. But it created a system that back in 2013 depended on just 9 ugly planes flying the same routes every single day. And now there's no going back. Boeing and Airbus are locked into distributed manufacturing. The cost savings are too significant. The political benefits too valuable, which means they're locked into depending on these absurd-looking cargo aircraft. The Beluga, the Dreamlifter, the Beluga XL. Billion-dollar solutions to problems nobody saw coming. The ugliest planes in the sky enabling the most advanced passenger aircraft ever built. And without them, the entire commercial aviation industry grinds to a halt. If this deep dive into aviation logistics blew your mind, smash that like button. Subscribe for more stories about the hidden systems running our world. Turn on notifications. Question for the comments. Should Boeing and Airbus move manufacturing back to centralized locations? Or is distributed production worth the dependency on these ugly planes? Thanks for watching. See you in the next one.